Yes, sir. Yes, this is now I am going to tell how the timing protocol it is works on the stop and wait protocol. Okay, so this is what the timing protocol. So now I am going to send the data from sender to receiver, and the receiver will give back the acknowledgement to sender. So this is the one transaction. Okay, in between, okay, the data will be lost. Okay, the sender it is going to send the data to receiver until the acknowledgement get back from the receiver side. Okay, and receiver side, then only it is going to send the next packet to receiver. So in between the data will be lost. Okay, how the data will be lost. Okay, during that time, or like how the sender and receiver it is going to knows. Okay, if the sender it is going to send the data, then till it is going to waiting for the receiver acknowledgement, but receiver also it is going to waiting for the sender data. Okay, but it is not happen in between. Okay, it is not happen the given amount of time, so that they are also waiting long time and sender also waiting long time. Okay, in between there is nothing transaction will be happen means. So during that time we let you know that okay, so something happen in between the transaction means there is there will be loss of data, or there will be a connection problem or some IC problem like that we have to think, and there during that time we have to stop the transaction. So this is what our stop and wait protocol will be works. Okay, like that I have sent so many like a request from sender to receiver, and like again the like acknowledgement during that acknowledgement time also, that the sender side also it may be happen for the acknowledgement loss means, like that will be packet loss. Okay, so this is what happened here. The second step is, the second one is, this is the one of the other topic. Okay, that is the HDLC topic. Then what is the HDLC stands for is high level data link controller. Okay, the high level data link controller it is going to tells about the bit oriented protocol. Okay, the character bit oriented protocol we already discussed in previous PPT. Okay, what is that character bit oriented protocol? Okay, how the flags are working, how the headers will working, how the escape character will work. Okay, everything we talk about in previous slides. Okay, and the bit oriented protocol for communicating over the point to point connection and multi point connections. Okay, so that we are using the HDLC method means high level data link control. The next one is configuration and transfer modes. Okay, the configuration transfer modes it is going to tell us about the how the data or how the link we are supposed to going to configure with the different transfer modes. Okay, so what is that we will discuss the now. Okay, the high level data link control it is going to provide two types of transfer modes. Okay, that is nothing but one is NRM mode and second one is ABM mode. Okay, then what is NRM mode? The NRM mode stands for normal response mode, and second one is ABM mode. It stands for asynchronous balance mode. Okay, then now what is NRM mode? Okay, the NRM mode is nothing but the station configuration will be unbalanced means the each device configuration should be not a balanced. Okay, means we have to send one data means is nothing but means one device here, call it as a primary device or primary station, and other device here working as the multiple other device it is going to consider as a secondary station. Okay, means a primary station can send the comments, and other secondary stations can only the response. And second, next one is ABM, like asynchronous balanced mode. It is the configuration is balanced. Means how means I'll tell in next diagram. Okay, this is what our NRM mode. Okay, the NRM mode, it is this is what the primary data or primary device. It is going to configure the secondary mode. Means it is going to tells the comment, it is going to request the it is going to request the message from primary to secondary. The secondary nodes, it is going to give the response back to the primary node. Okay, this is what we call it as a single point connection or point to point method. In that multi point connection or multi point structure, means one like only one node it is going to send the data, and multiple nodes or multiple secondary devices, it is going to give the response back to the primary node. So this method we call it as a multi-point links. Then second one is like this what asynchronous mode. Okay, our asynchronous mode, here primary and secondary devices not there. Means here all the device, means the source side and receiver side. Okay, here the source has a request, means here the source, the sender, it is act as a both the receiver and sender. At the receiver side, it is going to act as a receiver and sender. Means it is going to send the request as well as response. Okay, from one side. In that, in other side, in that side receiver also, it is going to send the request as well as the response. So this method we call it as a ABM method. Means the links is a point to point, and each station can function as the primary and secondary. Here the both the device, it is going to act as a primary device and secondary device in the one single connection. The next method is framings. Yes, framings is nothing but, I told in like every each and every topic in overall this module, I've told the framings is nothing but it is going to manageable the data units. Okay, here how the frames will be happening. High level data link controller. Okay, the high level data link controller, it is going to contain three types of frames. The first one is I frames, second one is S frames, and U frames. Okay, then what is the stands for I frames? I frames is nothing but control field information frames, and the S frames is nothing but control field supervisory frames, and U frames is nothing but control field unnumbered frames. Then now we discussed one by one what is I frames. Okay, here each type of frame serves and the envelope of the transmission of different types of messages. Okay, then iframe is used to transport user data and control information relating to user data. Means it is going to transfer the user data, and that particular data it is going to control it the at the user side, means at the sender side. Then S frame is nothing but, I told it is a supervisory frames. Means it is going to monitor, or it is going to what is that, it is going to monitor at or it is going to maintain that particular information. Okay, then what is the U frame? U frame is nothing but it is the unnumbered frames. Unnumbered frames is nothing but it is going to reserved for system management. Means all the frames it is going to reserved in the device or in the system. Then so this is the format of our HDLC frame time. See here what like here high frames, it is going to contain flags, address, control, and user information, and this is also FCS, and this is a flag. Okay, like that in S frame, flag, address, control, FCS, there is here there is no any user information. Okay, because this was why, because there is no any information. Means our S frame, it is going to handle only supervisor. Means it is going to monitoring the address. So that is what this frame works. So that's what it is, no any information. Then U frame is, this is the unnumbered frame. Means the one system it is going to control all the data. So we need only flags, address, and control, etc. So this is what our HDLC frame format. Then what is the flag field here? Okay, in see in I frame, S frame, U frame. Okay, the flags are common here. So what is the here flag, address, and control? Here for all the free fields, these three methods are common. So then what is the flag field here? The flag field, it is going to contain the 8-bit sequence number with the sequence of bit pattern, okay, and it is going to identify the beginning and end of the frames, that particular pattern.